Article 527 of the National Electrical Code, or NEC, addresses temporary electrical power and lighting installations. This article's scope extends to various settings, including manufacturing facilities, which are considered temporary structures under this code. Therefore, the requirements outlined in Article 527 apply to manufacturing facilities, specifically regarding extension cords and ground fault circuit interrupters, or GFCIs. Extension cords used in these settings must be listed for hard usage and be grounded. This ensures they are durable enough to withstand the demands of a manufacturing environment and provide a safe path for fault currents. GFCIs are crucial safety devices designed to protect personnel from electrical shock. Article 527 mandates the use of GFCIs for all 120-volt, single-phase, 15-amp and 20-amp receptacles used in damp or wet locations, or where water is likely to be present. This requirement is based on the increased risk of electrical shock in such environment. When water is present, it reduces the body's resistance, increasing the likelihood of dangerous current flow through the body. GFCIs detect even small imbalances in current flow, quickly interrupting the circuit to prevent potentially fatal shocks. Logging and testing are essential components of maintaining electrical safety in temporary installations. NEC Article 527.5b requires that all extension cords and GFCIs used in temporary electrical installations be tested and logged. Extension cords must be inspected before each use to ensure they are not damaged. This includes checking for cuts, abrasions, and other signs of wear that could compromise their insulation. Any damaged cords must be removed from service immediately. GFCIs must be tested monthly to ensure they are functioning correctly. This testing involves using a GFCI tester to simulate a ground fault and verify that the device trips and interrupts the circuit. Records of these tests should be maintained to demonstrate compliance and track the performance of the GFCIs over time. In addition to Article 527, several other NEC sections may also apply to electrical installations and manufacturing facilities. Article 400 covers flexible cords and cables, providing requirements for their construction, installation, and use. Article 430 addresses motors, motor circuits, and controllers, which are commonly found in manufacturing equipment. Article 440 covers air conditioning and refrigerating equipment, which are often used for climate control in manufacturing environments. Article 500 addresses hazardous, classified locations which may be present in manufacturing facilities where flammable or explosive materials are handled. It is crucial to consult with a qualified electrician to ensure compliance with all applicable NEC codes and regulations. Electrical codes are complex and can be difficult to interpret. A qualified electrician has the knowledge and experience to ensure that electrical installations are safe and compliant with all applicable requirements. Here's a more detailed breakdown of each relevant NEC article. Firstly, Article 527, Temporary Electrical Power and Lighting Installations, covers the requirements for temporary electrical installations used during construction, remodeling, maintenance, repair, or demolition of buildings, structures, equipment, or similar activities. This article provides specific guidance on the use of temporary wiring methods, grounding and bonding, overcurrent protection, and other safety measures to minimize electrical hazards on job sites. Secondly, Article 400, Flexible Cords and Cables, outlines the requirements for flexible cords and cables used for various electrical applications. This article specifies the types of cords and cables that are permitted for different uses, as well as the proper methods for connecting, supporting, and protecting them. It also addresses the ampacity, or current carrying capacity, of flexible cords and cables, and the requirements for their insulation and grounding. Thirdly, Article 430, Motors, Motor Circuits, and Controllers, covers the requirements for motors, motor circuits, and motor controllers used in industrial, commercial, and residential applications. This article provides detailed guidance on the selection, installation, and protection of motors and motor circuits, as well as the requirements for motor control devices such as starters, controllers, and overload relays. It also addresses the sizing of conductors, overcurrent protection devices, and disconnecting means for motor circuits. Fourthly, Article 440, Air Conditioning and Refrigerating Equipment, outlines the requirements for air conditioning and refrigerating equipment, including the electrical components and wiring associated with these systems. This article covers the selection and installation of disconnecting means, overcurrent protection, and grounding for air conditioning and refrigerating equipment. It also addresses the requirements for motor compressors, which are commonly used in these systems. Fifthly, Article 500, Hazardous Classified Locations, addresses the requirements for electrical equipment and wiring in hazardous locations where flammable gases, vapors, or dust may be present. This article classifies hazardous locations into different classes and divisions based on the type and frequency of the hazard. It also specifies the types of electrical equipment that are permitted in each class and division, as well as the requirements for wiring methods, sealing, and bonding to prevent explosions and fires. In manufacturing facilities, several types of equipment and systems commonly fall under these NEC articles. Motors are used extensively to power machinery, equipment, and conveyor systems. Article 430 provides requirements for the installation, protection, and control of these motors. Air conditioning and refrigeration equipment is used to maintain comfortable working conditions and to cool processes or equipment. Article 440 addresses the electrical requirements for these systems. Flexible cords and cables are used to connect portable tools, equipment, and lighting fixtures. Article 400 specifies the types of cords and cables that are suitable for different applications. Hazardous locations may be present in areas where flammable liquids, gases, or dust are handled or stored. Article 500 provides requirements for electrical equipment and wiring in these areas. Understanding these NEC articles and how they apply to manufacturing facilities is essential for ensuring electrical safety and compliance. Extension cord requirements. Firstly, extension cords must be of the appropriate type for the environment in which they are being used. In manufacturing facilities, this typically means using heavy-duty, hard-usage cords that are designed to withstand the rigors of industrial environment. These cords should be listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL, to ensure that they meet safety standards. Secondly, extension cords should be inspected regularly for damage such as cuts, abrasions, or frayed insulation. Damaged cords should be removed from service immediately to prevent electrical shock or fire hazards. Thirdly, extension cords should be used in accordance with their ampacity rating. Overloading an extension cord can cause it to overheat and potentially start a fire. Fourthly, extension cords should be properly grounded. This means that the cord should have a 3-prong plug and be plugged into a grounded receptacle. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. Fifthly, extension cords should not be run through doorways, windows, or other openings where they could be damaged. They should also not be run under carpets or rugs, as this can trap heat and create a fire hazard. GFCI requirements. Firstly, GFCIs are required in wet or damp locations such as bathrooms, kitchens, and outdoor areas. This is because water is a good conductor of electricity and the risk of electrical shock is higher in these locations. Secondly, GFCIs are also required in construction sites where temporary wiring is often used. Construction sites are typically wet or damp, and workers are often exposed to electrical hazards. Thirdly, GFCIs should be tested regularly to ensure that they are functioning properly. The manufacturer's instructions will provide information on how to test the GFCI. Fourthly, GFCIs should be replaced if they fail to test properly or if they are damaged. GFCIs are designed to protect people from electrical shock, and it is important to make sure that they are working properly. Fifthly, GFCIs should be installed by a qualified electrician. Installing a GFCI is not a difficult task, but it is important to make sure that it is done correctly. A qualified electrician will be able to install the GFCI properly and ensure that it is working safely. In addition to the specific requirements for extension cords and GFCIs, There are also some general safety practices that should be followed in manufacturing facilities. All electrical equipment should be properly grounded. This includes machinery, tools, and appliances. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. All electrical equipment should be inspected regularly for damage. This includes checking for loose wires, frayed insulation, and other signs of wear and tear. Damaged equipment should be repaired or replaced immediately. Workers should be trained on how to work safely with electricity. This includes teaching them about the hazards of electricity and how to avoid them. Workers should also be trained on how to use electrical equipment properly and how to respond to electrical emergencies. Electrical panels and disconnects should be kept clear and accessible. This will allow workers to quickly shut off power in the event of an emergency. Lockout/tagout procedures should be followed when working on electrical equipment. This involves disconnecting the power to the equipment and placing a lock and tag on the disconnect to prevent someone from accidentally turning the power back on while work is being performed. Using personal protective equipment, or PPE, such as rubber gloves and insulated tools, when working with electricity can reduce the risk of electrical shock. Performing regular inspections of electrical systems and equipment helps identify and correct potential hazards before they cause accidents. Keeping detailed records of electrical inspections, maintenance, and repairs provides a valuable resource for tracking the condition of electrical systems and identifying trends that may indicate potential problems. Consulting with a qualified electrical engineer or contractor can provide expert advice on electrical safety and compliance. They can help to assess the electrical hazards in a manufacturing facility and develop a comprehensive safety plan. Here is some additional information about temporary electrical installations. Firstly, temporary electrical installations are often used during construction, remodeling, maintenance, repair, or demolition activities. Secondly, these installations are typically in place for a limited time, usually no more than 90 days. Thirdly, temporary electrical installations must meet the same safety requirements as permanent installations. Fourthly, the NEC provides specific requirements for temporary electrical installations in Article 527. Fifthly, temporary electrical installations must be inspected and approved by a qualified electrical inspector before they are put into service. Here is some additional information about flexible cords and cables. Firstly, flexible cords and cables are used to connect portable equipment and appliances to a power source. Secondly, these cords and cables are typically made of stranded copper conductors and are insulated with rubber, plastic, or other flexible materials. Thirdly, flexible cords and cables are available in a variety of sizes and types to meet the needs of different applications. Fourthly, the NEC provides specific requirements for flexible cords and cables in Article 400. Fifthly, flexible cords and cables must be protected from damage and abuse. Here is some additional information about motors, motor circuits, and controllers. Firstly, motors are used to power a wide variety of equipment and machinery. Secondly, motor circuits are the electrical circuits that supply power to motors. Thirdly, motor controllers are used to start, stop, and control the speed of motors. Fourthly, the NEC provides specific requirements for motors, motor circuits, and controllers in Article 430. Fifthly, motors, motor circuits, and controllers must be protected from overloads, short circuits, and ground faults. Here is some additional information about air conditioning and refrigerating equipment. Firstly, air conditioning and refrigerating equipment is used to cool and dehumidify air. Secondly, this equipment is commonly used in homes, offices, and industrial facilities. Thirdly, air conditioning and refrigerating equipment typically uses a refrigerant to transfer heat from one location to another. Fourthly, the NEC provides specific requirements for air conditioning and refrigerating equipment in Article 440. Fifthly, air conditioning and refrigerating equipment must be properly grounded and protected from overloads, short circuits, and ground faults. Here is some additional information about hazardous classified locations. Firstly, hazardous classified locations are areas where flammable gases, vapors, or dust may be present. Secondly, these locations are classified according to the type and frequency of the hazard. Thirdly, electrical equipment used in hazardous classified locations must be specifically designed and approved for use in those locations. Fourthly, the NEC provides specific requirements for hazardous classified locations in Article 500. Fifthly, electrical equipment in hazardous classified locations must be properly sealed and grounded to prevent explosions and fires. Following these guidelines will help ensure a safe and compliant electrical environment in manufacturing facilities, minimizing the risk of electrical hazards and protecting workers from injury. Regular inspections, testing, and maintenance are crucial for maintaining electrical safety. Electrical safety is an ongoing process that requires constant vigilance and attention to detail. By implementing a comprehensive electrical safety program, manufacturing facilities can create a safer work environment for their employees and prevent costly accidents. Remember to always consult with qualified professionals for specific guidance related to your facility's electrical systems and safety needs. Compliance with the NEC and other applicable standards is essential for maintaining a safe and efficient workplace.